Have you ever just stopped and noticed that the world is, well, full of patterns? Seriously, think about it. From the way planets move around the sun to, I don't know, the price of your morning coffee, at their very core, all of these things are about connections, how one thing affects another. So today, let's dive into the mathematical tools that let us talk about these connections with absolute precision. And believe me, that is no exaggeration. This quote from Berthollet, it absolutely nails it. The ideas we're going to explore today, relations and functions, they aren't just some abstract stuff for a textbook. Nope, they are the actual language we use to make sense of the universe around us. So yeah, that brings us to the big question, right? How do you go from just noticing something in the real world, something that's maybe a little messy, to creating a precise, predictable, mathematical rule? Well, it's a journey, and it all starts with the simple act of pairing things up. Okay, before we can even think about making rules, we have to get organized. We need a system for looking at all our options. So let's start with a really simple hands-on example. Let's make this super concrete. Imagine you have two sets of things. In set A, you've got a couple of colors, red and blue. And in set B, you've got some objects, a bag, a coat, and a shirt. The very first step to finding any kind of connection between these is to figure out every single possible way you could pair a color with an object. And boom, here they are. You can take red and pair it with the bag, red with the coat, red with the shirt. Then you do the exact same thing for blue. You end up with 6 possible pairs in total. We've literally listed every single combination. Now this complete list, this universe of all possibilities, it actually has a formal name in math. It's called the Cartesian product. Sounds a little fancy, right? But all it means is exactly what we just did, the set of all possible ordered pairs. And that word ordered is really important here. It means that the pair red bag is different from the pair bag red. The order matters. And the best part is how incredibly predictable this is. You got 2 colors and 3 objects. That's just 2 times 3, which, you guessed it, gives us 6 total pairs. No guesswork at all. So this is our foundation. We've created this sea of possibilities. Now let's find some meaning in it. All right, so having every possible pair is a great start. But honestly, it's usually way too much information. We're not typically interested in every combination. We only care about the pairs that have some kind of meaningful connection. We need a way to filter out all the noise. We need a rule. Just look at this example. We've got a set of letters, A, B, C, and a set of names. Now, that's 3 letters times 5 names, which gives us 15 possible pairs. You can see it right there. It's a total jumble. Most of these connections are completely meaningless. But what happens if we introduce a simple, intuitive rule? Let's say we're only interested in the pairs where the letter is the first letter of the name. This one simple rule is about to act like a filter and bring order to that chaos. And just like that, look. The chaos is gone. Our huge list of 15 pairs instantly shrinks down to just these 4 meaningful connections. That is the power of a rule. And this new filtered down list, well, it has a name too. We call it a relation. So here's the key takeaway. A relation is just a subset of that giant Cartesian product we started with. It's not the whole shebang. It's just the collection of pairs that actually matter to us, the ones that follow our rule. But we can get even more specific and a whole lot more powerful. And this brings us to the main event, the function. A function is a special, super reliable, VIP kind of relation. It adds one more critical rule to the mix that makes it the bedrock of pretty much all of math and science. And here it is. This is the golden rule. For something to be a function, every single item in your starting set has to be paired with one and only one item in the second set. Not 0 items, not 2 or 3, exactly 1. This unique output is called its image. You know, the best way to think about this is a vending machine. It's a perfect analogy. When you press button C4, you expect to get exactly 1 soda, right? You'd be pretty confused if nothing came out, and you'd be totally shocked if 2 different things came out at once. That reliability, that 1 input gives you 1 output deal, that's the very soul of a function. Okay, let's look at this side by side. On the left, we have a function. See how the inputs 2, 3, and 4 each go to exactly 1 output? Now, it's totally fine that 2 and 3 both point to the same output, which is 1. The key is that neither of them points to more than one thing. But now, look at the right. We have a problem. The input 2 is trying to go to two different places at once. It's pointing to both 2 and 4. That's our broken vending machine. That is not a function. So once we have these rules, these functions, we can actually draw pictures of them. And what's so amazing is how different rules create their own unique visual fingerprints. So let's take a quick tour through a gallery of a few famous functions. First up, we have f of x equals x squared. The rule is dead simple. Whatever number you put in, the output is just that number times itself. And look at the beautiful symmetrical curve that rule creates. It's called a parabola. See how it dips down and then rises back up, like a perfect mirror image? Now let's just tweak that rule ever so slightly. Instead of x squared, let's do x cubed. And wow, the visual story completely changes. Now we get this distinct S-shaped curve. A tiny, tiny change in the rule creates a completely different pattern. And for something totally different, here's the absolute value or modulus function. Its rule is also simple. It just makes sure the output is always positive. And that simple rule gives us this sharp V-shaped graph. Each function really does tell its own unique story through its shape. So we've gone from pairs to relations to these super special rules called functions. But why does any of this actually matter outside of a math class? Well, because, as it turns out, this is the very language we use to describe how reality works. The person who first really locked this down was Gottfried Wilhelm Leibniz. And I love this. He thought of a function as a mathematical job. An input comes in, the function does its specific job, and one single predictable output comes out. It's just a perfect way to model cause and effect. So let's just recap our journey here. We started with this chaotic sea of all possible pairs, that Cartesian product. Then we used a relation to filter it all down to just the connections that made sense. And finally, we perfected that connection with the function, creating this precise, reliable, predictive tool. This isn't just numbers on a page. This is the language of science. And so I'll leave you with this final thought to chew on. Think about your own daily life. The time it takes your coffee to cool down, the price of gas based on the day of the week, the amount of tax you pay based on what you earn. Which of these patterns has that strict one input gets you one output rule? What in your world behaves like a perfect function?